Welcome everyone. Whether you're located in Australia or abroad, you're in for a bit of a treat and an event tonight. I'm Darshan, the National Coordinator on behalf of the Moon Village Association, and tonight we'll be hosting this event as a celebration of the International Moon Day. This will be alongside my co-host Kaya, Daniele, and Summer as well. For those that may be hearing of the Moon Village Association for the first time, it was created in 2017 as a non-governmental organization in Vienna, in Austria, and acts as a permanent global informal forum for stakeholders like governments, industry, academia, and the public interested in the development of the Moon Village. The Moon Village fosters cooperation amongst existing or planned public or private global moon exploration missions, with over 600 participants, 33 institutional members from over 50 countries. Safe to say we have a diverse array of technical, scientific, cultural, and interdisciplinary fields covered by this. But before we begin the official events of the evening, for those that may not be from Australia, zooming into this event, we like to commence events with an acknowledgement of country. In the spirit of reconciliation, the Moon Village Association and its partners today acknowledge the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respects to the elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. Well, I'll start off with the quote, "That's one small step for man, one giant leap for mankind." These words mark the most humanity-defining moments in history. But yeah, did you actually know that Australia played a key role on this day in 1969? We were front and center in beaming back images back to households across the world on this momentum occasion. On December 9th, 2021, the UN General Assembly approved the commemoration of this momentous occasion put forward by the Moon Village Association, and now it becomes the day we honor and celebrate the outcomes of the Apollo 11 mission, especially marked by those words. The UN's approval of the proclamation to celebrate the anniversary of the first human landing on the moon, now known as International Moon Day, is the event to mark all space events across the world. But for Australia, it holds a special place as well, as we look to go to the moon for the first time no earlier than 2026 through the development of our own Foundation and Services rover. Australia's opportunity to visit the moon in years to come not only highlights the capability that the nation is investing in, but also highlights the uplift and inspiration that we will have amongst the entire space community, irrespective of age, gender, religion, or what your personal background could be. To celebrate this momentous occasion, we've enlisted a star lineup of emerging and established professionals across Australia and the United States. The program for this evening will therefore take form of an official welcome address before we progress into three of our key speakers who will discuss a number of topical domains for discussion, especially relating to Australia's participation in further lunar activities in the wider space realm, before we move on to our keynote speech for the evening. We will then conclude this evening by opening up a series of networking sessions to be explained by Summer in a moment. But first, to kick things off, I shall hand over the mic to Dr. Alice Gorman, Vice Chair of the Adelaide section of the American Institute of Aeronautics and Astronautics, for the official welcome address, as well as Summer before we go back to Kaya and Daniela shortly after. But by way of introduction, Dr. Alice Gorman is an internationally recognized leader in the field of space archaeology. Her research on space exploration has been featured in the magazines of National Geographic, New Scientist, and the Archaeology magazine. She's a faculty member of International Space University's Southern Hemisphere Space Program, and like I said before, the Vice Chair of AIAA. She's also a founding member of Archaeology, Science, and Heritage Council for All of Moonkind. Over to you, Alice.
Thank you, Darshan, for that welcome. And I'm really delighted to be here today talking to you all from the lands of the Kaurna people of the Adelaide Plains. As Darshan said, I'm representing the Adelaide section of the American Institute of Aeronautics and Astronautics as its vice chair. And I want to point out that despite its name, the AIAA is a global organisation and has been in Australia since 1998, which incidentally makes it exactly the same age as the International Space Station. So we're also celebrating this first International Moon Day. Over 20 years ago now, a few of us began creating the field of space archaeology. At the time, many thought that looking at lunar landing sites as cultural heritage was very out there and maybe a little bit too kooky. Surely they thought this stuff was too recent and too technological to be culturally significant. But what we actually have on the moon is over 100 locations where humans have landed material over more than 60 years of lunar exploration, from the landing of the Soviet space probe Lunar 2 in 1959, the first human object to touch the moon, to the most recent site, which is the impact crater made by a Chinese Long March rocket falling onto the dark side of the moon just earlier this year. So ideas about space heritage are no longer considered marginal and have even been enshrined in the US's Artemis Accords, of which Australia is a signatory. And I'm sure Michelle is going to talk a lot more about this later on. So as a space archaeologist, I've been advocating for cultural heritage to be recognised as an integral part of the sustainable use of the moon. And I'm currently also a vice chair of a Moon Village Association initiative, the Global Expert Group for Sustainable Lunar Activities, otherwise known as the GEGSLA. The GEGSLA is creating a document of key principles for future lunar activities, which will be presented to the United Nations Committee on the Peaceful Uses of Outer Space later this year. Protecting natural and cultural heritage values is a big part of this document. So just as a taste, I'm going to share with you two of the key principles. Firstly, it is acknowledged that access to cultural heritage is a human right according to the UNESCO Universal Declaration on Cultural Diversity and the UN Universal Declaration of Human Rights, and that lunar activities should be conducted to the greatest extent possible to avoid causing adverse changes to sites with known cultural or natural significance. And if you want to have a say in this document, and particularly the heritage parts, we currently have an open questionnaire for consultation, which is online on the Moon Village Association website. And we'd really encourage everybody to come and have a look at these questions. It's about all aspects of operating on the moon. And I'll drop the link into the chat in a bit later on. So another project I've been working on is the Declaration of the Rights of the Moon, which grew out of a series of public forums organised by Thomas Gooch under the auspices of the Moon Village Association. So you can see the Moon Village Association is a very progressive organisation in discussing these complex ethical issues around the moon. So our little working group released a draft of the Declaration of the Rights of the Moon in February last year. And to finish, I'm going to give you two of these as well for your consideration. So from the draft declaration, the moon possesses fundamental rights which arise from its existence in the universe, including the right to maintain ecological integrity and the right to remain forever a peaceful celestial entity unmarred by human conflict or warfare. So with those thoughts, I'd like to say welcome everyone to tonight's event and happy International Moon Day to you all.
Thank you for that, Alice. Before we move through, I just wanted to quickly jump in and talk about the networking session that's going to be happening at the conclusion of the webinar. In a moment, I'll be posting a Zoom link in the chat. So for anybody that's wanting to join, you can copy, save, and use that link later on to access the networking session. I'll also post a link again towards the end of the webinar for anyone that might miss it. The networking session will consist of a Q&A at the beginning. Some of our wonderful speakers have agreed to stick around and answer some questions. So between now and then, if you have any questions for any of the speakers or even just any points that you'd like to discuss further, please feel free to pop them in the Q&A area or in the chat, and I'll collate those and ask the speakers when we get to the networking session. We'll then also have more of an open discussion session towards the end of the networking as well. So between now and then, feel free to use the chat amongst yourselves as much as you like for any discussion between you guys. And please enjoy the webinar. I'll talk to you guys later on, and I'll hand over to Kaya now. Thank you.
Hi, everyone. Thank you, Summer. Thank you, Alice and Darsh. I wish to begin by acknowledging the Boonwurrung people of the Kulin Nation, the traditional custodians of the land on which I'm presenting from here in Melbourne. This is such an inspiring night or a day, depends on where you are participating from. Our team of AIAA members, recent ISU, SHSSPs, and space enthusiasts based here in Melbourne, including Simon Russell, you've already met, and Daniela Dallari. Daniela, you're here. We're started.
I'm here.
Yeah, I think you're overseas, right? So we started the process of forming an AIAA Melbourne section, and this is actually our first public announcement and our first event we are co-organizing. On that note, we are inviting both established and emerging space and aviation leaders in Victoria and in Tasmania to join this initiative and help the AIAA members to better connect with already active sections in Australia, as well as with others overseas. So again, you're most welcome to get in touch if you're interested in being involved. And Daniela.
Thank you, Kaya, and what a fantastic announcement. I will just start saying how grateful I am to have met Summer and Kaya, and I've been working with them on this project about having a AIAA section started with an idea by Dr. Alice Gorman. So it's a fantastic feeling to be able to be here and have that announcement that Kaya just made. It means a lot for everybody in here, I believe. And when we started discussing about the AIAA section in Melbourne, we decided a little bit, what was important for us and how we'd be dividing our tasks. And I put my hand up for the mentoring program that we will be organizing and running. And the reason why I did that is I think it's a good mentoring program is about nurturing the emerging talents in the aerospace and aeronautical field. And it's the best way to build meaningful relationships, which is, both of these things are things I'm very passionate about, and I see that as a key way to move forward with all of our endeavors. And I would like just to take the opportunity to remind that a mentorship relationship is not just good for the mentees; it's also very, very good for the mentors. It helps the mentors to connect to the new generation, help the mentors to test themselves and learn in return from the mentees as well. So I will just close with a call for action for anyone that is in Victoria and Tasmania to please join AIAA if you're interested, and definitely join the mentorship program. Which I will also inform you in here that we spoke with the AIAA section in Adelaide, and we'll be combining the two sections in terms of the mentorship program. So the mentorship program will be one spanning across the two states, just to increase the opportunities for people to meet other people around and expand the possibilities of mentorship. So thanks again, everybody, and enjoy this wonderful event.
Thanks, Daniele. So next up, we have Kerry Doherty from the Australian Space Agency, who will be treating us to a session on partners in space and what it means for Australia's involvement in lunar exploration. Kerry is a Senior Heritage and Outreach Officer for the Australian Space Agency's Inspire program, focused on promoting awareness of Australia's past, present and future in space and encouraging interest in STEM and future space careers. An elected member of the International Academy of Astronautics, Kerry is a space historian, a curator, an educator, an author, and serves on several international committees on space history, education, and space museums. I'll hand the mic over to you, Kerry.
Okay, let me see if I can share my screen. Are you able to see it? Good. Now let me see if I can get it to go to full screen mode. Okay, I'd like to thank Kaya very much for inviting me to speak today to provide a little bit of background to Australia's historical involvement in lunar exploration. Because although, pardon me, Dash alluded to it earlier, a lot of people aren't really aware of the role that Australia has played in the past in lunar exploration. And in fact, when President Kennedy committed the United States to the Apollo program in May of 1961, Australia was actually already a part of the American space program, specifically involved in providing tracking station facilities for the US satellite program, for the emerging human space program at that time, and also for NASA's just beginning deep space program, which of course is what the moon would, the moon exploration would come under. And you'll see on the little diagram here, there are 3 stations around the world. And the idea was that the base station was in Goldstone in California, able to reach out and connect with NASA's deep space probes. But because the Earth turns, you need to have at least 3 stations around the world that are able to be facing in the direction in which space probes are heading out into the solar system, so that there's always one station that can be in communication at all times. So the original deep space network that NASA created began with Goldstone in California, then Woomera in Australia, a site called Island Lagoon, and you can see why it gets its name from the picture here, the salt lake with the volcanic island cone in the middle. And the other site was initially in Johannesburg in South Africa and later moved to Spain. So Australia was actually the site of the very first deep space network station outside the United States. And this station at Island Lagoon played a really important role in the precursors to the Apollo program. So the very first exploration of the moon. The Ranger program, which was a hard lander, which is a polite way of saying that it crashed into the moon, taking pictures all the way down so that NASA could get an idea of the lunar surface. And then the Lunar Orbiter program, which did exactly what its name said that it would do, and orbited the moon, actually taking a range of images across areas that NASA was thinking of planning or thinking of using as the Apollo landing sites. So they provided a range of both broad area and close-up images of the moon for Apollo planning. And interestingly, some of you may not be aware that the very first picture of the Earth from the moon was not taken by Apollo 8, but by Lunar Orbiter 1. And that's this image you can see here. At the time, it was actually considered one of the pictures of the century because it was that very first view of the Earth in space. And even though, of course, it was later lost in the glory of the Apollo 8 image of the Earth from the moon, this was the very first time we saw our home as that fragile spaceship Earth. So our partnership with NASA grew over the 1960s, and there was actually a second deep space network station built in Australia near Canberra called Tidbinbilla. It's now the longest serving NASA facility in Australia. It operates under the title of the Canberra Deep Space Communications Centre now, and is involved in tracking of all, not only NASA's deep space probes, but those of many other countries as well, ESA, JAXA, India, Japan, and so on. So, but it was opened in 1964, and just in time, in fact, it became operational to receive the first images from Mars, from NASA's Mariner 4 space program. And because these images actually disappointed people a bit at the time, because Mars looked an awful lot like the moon. And we were getting much clearer pictures of what the moon looked like during this period, because not only did we have Lunar Orbiter going around the moon, but Tidbinbilla was responsible for a lot of communication with another program called Surveyor. And as you can see, this is a photo taken from Apollo 12, which actually landed near the Surveyor 3 spacecraft and went over to pay it a visit and even bring a little bit of it back to Earth for analysis. But this particular mission was initially controlled through the Tidbinbilla tracking station in Australia. And as it landed on the moon in order to test that it was actually safe for the Apollo astronauts to land, because they still didn't know at that point whether the surface of the moon was coated in so much dust that a spacecraft would just sink into it. To say, we had a role in all these precursor programs that ensured that it was actually safe for the Apollo astronauts to make that mission to the moon. So finally, in around 1967, NASA was getting ready for the Apollo program, and they established the Honeysuckle Creek Manned Spaceflight Tracking Station, as it was called, again near Canberra. And this was specifically designed to communicate with the Apollo spacecraft on the way to the moon and while they were in orbit and conducting operations on the moon as well. In addition, we had another tracking station primarily for the Earth orbiting satellites, but Auroral Valley, again established near Canberra, was also used for receiving the data from the Apollo lunar surface packages. So whenever Australia was facing towards the moon, we'd be receiving the data that the instrumentation packages from all the Apollo missions left on the lunar surface. We were part of what was called the SPAN network, the Solar Particle Alert Network, which was a network of observatories around the world that kept an eye on the sun to make sure that there was not going to be any dangerous solar activity that could spew out sort of dangerous radiation towards the moon, either just before the astronauts were going to leave the Earth or potentially while they were on the moon. They might need to know to leave and get back to the Earth fairly quickly, or as quickly as was possible, if there was going to be potentially heavy radiation dosage reaching the moon. And Australia was also the base during the re-entry of Apollo missions for the Orion aircraft. These are the Apollo Range Instrument aircraft, and they were like flying tracking stations to actually cover those areas that the land tracking stations around the world did not provide coverage for returning Apollo spacecraft. So we were partnering with NASA in various ways across the Apollo program. And in fact, by 1969, Australia had the largest number of NASA tracking stations outside the United States. And as you can see from this map here, we were covering the Manned Spaceflight Network, the Human Spaceflight, the Deep Space Network, and the STADAN network, the Space Tracking and Data Acquisition Network, which was specifically for the Earth orbiting satellites. Now, actually communicating with the Apollo missions on the moon was quite complex because you had two spacecraft operating independently. You would have the command service module in orbit around the moon, the lunar module on the moon, astronauts operating on the lunar surface as well. So there were quite a lot of requirement for complex communications setups. And because of that, it was actually necessary for the prime station, like Honeysuckle Creek, to be matched with a deep space network station so that between the two, they could actually control or communicate with both the command module in orbit around the moon and the lunar module and the astronauts on the surface. And you can see here on this map that Honeysuckle Creek and Tidbinbilla were connected by a microwave link to do that. But in addition, in order to bring back television from the moon, the television was very low resolution because they could only, NASA had such weight restrictions on the lunar module that they could only afford a very, very basic television system that was not going to require too much heavy equipment. And this meant that the signal coming back to the Earth was quite low resolution. So NASA's preference was to have as large an antenna as possible receiving that signal. In the United States, they had the large dish, the 64-metre dish at Goldstone. And in Australia, we had the Parkes radio telescope. So it was not a tracking dish, a radio telescope, but it had in fact, it was the prototype for the 64-metre dish at Goldstone. And so this is actually operated by the CSIRO, and NASA, pardon me, NASA requested that CSIRO become part of the Apollo communications network for Apollo 11 and some of the later Apollo missions in order to bring the television to us here on Earth. And I'd like to just also note that there were various Australian scientists who were involved in the Apollo program. I'll just quickly mention a couple of them. We had John Colvin, who was an ophthalmologist with the Australian Air Force, who developed things like tracking targets. He also developed the special anti-glare sunglasses. You can just see Buzz Aldrin putting in the pocket of his jacket there. Professor Ross Taylor at the Australian National University, who helped set up the Lunar Receiving Lab and then was involved in the analysis of the very first rocks brought back from Apollo 11. Another very prominent person involved was Professor Brian O'Brien, a physicist, and he had 5 instruments on the lunar surface across the period of the Apollo missions. And one in particular, this very tiny little item here, which I've indicated with the arrow, this is a dust experiment. And even though it's a very tiny, very simple experiment, the results that he got from that were incredibly important because they've actually taught us a lot about the rather unusual behavior of lunar dust. You often notice in the pictures of the Apollo astronauts how they're covered with dust in their, especially along the legs and the arms of the suits. And this was a result of interesting electrostatic effects that actually caused the lunar dust to rise or levitate across the lunar day so that it could coat itself all over parts of the astronaut suits and indeed all their equipment in ways that they hadn't expected. And we now know that in fact lunar dust is going to be one of the big hazards on the moon for future activities, and it's very much part of the legacy that Professor O'Brien has left us from his research in lunar dust. Now, it's already been mentioned, of course, that you've all seen these images, I'm sure, and anybody who was alive at the time remembers sitting in front of their television watching Armstrong take that one small step for mankind. And the images that we saw around the world actually came through Australia. They came through Honeysuckle Creek and the Parkes Radio Telescope. At the time, both Goldstone and Parkes and Honeysuckle in Australia were all receiving the television from the moon, but they had a lot of trouble with their signal initially at Goldstone, and the signals from Honeysuckle were actually the best initially as Armstrong was coming down the ladder and stepping onto the lunar surface. So the first 8.5 minutes of television from the moon came through Honeysuckle Creek, and the remainder of the broadcast came through the Parkes Radio Telescope, which then had a much better picture than Honeysuckle. And I just thought I'd throw this in for those of you who've never seen it. This is the actual log from Honeysuckle Creek, and you can see the entry here, which says CDR Commander on the Moon, and you'll see he's actually put the 3 exclamation marks there. And the confirmation from NASA that it was the live signal from Honeysuckle Creek and from Parkes sending the signals to the rest of the world. So they came from the individual stations to Sydney and then were sent via satellite back to the United States and then rebroadcast from there to the rest of the world. So Australia was involved in the Apollo program all the way through. Honeysuckle Creek and Tidbinbilla working together, and also the Parkes when they needed television capacity. We've also supported various of the other probes that have been sent to the moon since then, from the United States, from India, from Europe, but now Australia is actually going to the moon ourselves. We have a program, the Australian Space Agency has a program in planning called Trailblazer, which is actually going to draw on our world-leading capabilities in remote operations. And what we're going to do is fund the development of a semi-autonomous Australian-made rover. So this is a project which will allow Australian industry to demonstrate its skills and capabilities by actually operating a rover on the moon. NASA's going to provide us with the ride. the trip to the moon and will land us on the moon. And then the little rover will go out and collect lunar regolith samples, that is the lunar soil, as it were. That will be brought back to a NASA in situ resource utilization experiment for oxygen extraction. So our little rover, it's only going to be, one of these size of a bread box rovers. It'll be quite small, but it will show that we have the capability to do this kind of work and provide what we call foundational services for future moon and ultimately Mars missions, so that Australian industry will have a role in all kinds of very basic infrastructure type work as bases on the moon, settlements on the moon develop, and ultimately as we move out to Mars and maybe eventually into the rest of the solar system. So that's going to be a very exciting project coming up, being in development over the next couple of years. We expect that the rover will land on the moon around about 2026, 2027. And when Nate does his presentation about some of the involvement of Australian industry in going to the moon, he's going to tell you a little bit more about this and how it fits into the context of other Australian lunar activities. Thank you.
Thanks, Kerry. It's it's definitely a fascinating time, and someone that's quite obsessed with robotics. 2026 is definitely a year I'm just could not wait for. Something definitely exciting. So now we have Nate Taylor, also from the Australian Space Agency and a founding member of the International Space Universities Australia and New Zealand Alumni Association, who'll be highlighting what it means for Australia to become lunar beyond our current Australian footprint. He's a graduate in applied physics and mathematics from the Uni of SA, as well as an alumni from the International Space University itself. He works as a senior programs and operations officer at the Australian Space Agency's Space Discovery Centre and is a founding member of the Alumni Association. He actually describes himself as a bit of a enthusiast in space, but also defines his career pathway as being similar to an n-body problem, which I will say is the most unique bio I've ever heard of. So now I'll hand over to Nate to impress us all.
Thanks, Dash. I thought that adding that into my bio would be something that all space enthusiasts or space nerds, as I identify, would probably enjoy. I'll just share my screen with everybody. So just bear with me one moment. But while I'm doing that, I do want to acknowledge I'm coming to you today from the lands of the Kaurna people, and I do want to pay my respects to their elders past, present and emerging. And an interesting tidbit which I learnt just recently was thanks to Dwayne Hamaker. I was watching one of his lectures and he mentioned that Aboriginal astronomers would actually use the moon to identify times, the seasonal times, that it was the best time to fish in certain locations, which I thought was quite amazing. Among all of the other knowledge that they have, I thought that was particularly relevant for today. So it is my pleasure to join you here tonight. I think I'm very fortunate to be able to come along and speak to you all. My talk is about becoming lunar and going beyond Australia's footprint. So I really would like to look to the future with this talk. The contents of the talk hopefully give you a bit of an idea as to what I'm intending with this. There's plans in place around the world in terms of getting humanity back to the moon. And I think Australia's historical role or perception of our role in space hasn't necessarily been one of being on the forefront of these endeavours. And we have played an ancillary role, a very important one, one which has supported a lot of space activities for years, for decades. But I hope that with this presentation, we can kind of start to transfer that mindset or look at it in a different light, I suppose, and see Australia as really having an opportunity to leap forward in and be a leader in this field. So before I officially kind of get started, what I'd like to do is just invite everybody to take a moment to have a think about what that means for Australia, for us as individuals, for humanity, what it means to go back to the moon, and not just to visit or to conduct scientific studies, but to stay there, to leave the cradle of the Earth and to have a presence on another terrestrial body. So just think of that for a moment, because the ramifications of that to me are quite profound. They signify a real turning point in human history. And we often think about space in terms of the engineering challenges, of which there's many when we're talking about going to the moon, but also to a consideration which I know Alice would be great to speak to on this, would be about preserving the cultural heritage of achievements such as this as well. So this first image that I'm sharing with you is an artist's rendition of what a lunar habitat may indeed look like. And I'd like to just ask you all if you can indulge me to be a little bit interactive with me here, and just use the chat to put in the chat what it is you can see here. So what is it you can see in this photo? What would be required, I suppose, if we were going to live on the moon permanently? And can you see it here? So I'll just give you a moment. If you can pop what you can see in this image in the chat, that would be great. Yep, solar panels and energy. Protection from radiation, plants, yes. Use of regolith, yep. Are they buildings for waste management? Maybe they could be. Yep, ISRU for solar, local manufacturing, water collection, yep. People, of course, yeah, people. Oxygen production, shelter, yes. Rovers, absolutely. I mean, the list is essentially endless, right? A chill out room. I love that, Tim. That's great. The list is essentially endless because it's, well, what level of detail do you want to get to? How much do you want to mimic, I suppose, an environment here on Earth, obviously one that's contained and sealed, but how detailed do you want to go with it? And when I look at this image, I suppose I'm thinking of it through the lens of industry, because all of these things that you're listing in the chat require this interdisciplinary engagement in being able to achieve it. So when I think of the things in this photo, I'm thinking of the agriculture industry and applying our knowledge there in terms of generating a food source, obviously storing and receiving supplies and food sources from Earth as well. I'm thinking of transport systems, transit vehicles, EVA support, the supply chain that's involved with those things. I'm thinking of the people there and the medicine, the life support services. So yes, someone mentioned human waste, that's a consideration, air filtration, thermal and humidity control, pressurization of the modules. Yes, absolutely, entertainment, Sammy. I'm thinking of communications, so communications on the surface, those between the moon and the Earth, so some relay systems, something that supports SSA, so space situational awareness, and this is going to become even more important as lunar orbits become more congested. I'm thinking of construction industries for building these modules, for fitting them out. The infrastructure will need to land there to launch from the moon. The way we're going to have to manufacture things on the moon. I'm thinking about mining and using those resources that are there, the regolith, the water ice, potentially platinum group metals, which might exist there as well. Obviously energy production, storage, so whether that's renewable or nuclear, or if we're producing fuels as propellants for rockets to Mars or something like that. And I'm also thinking of research opportunities, whether they're exploratory or whether there's technology transfer. And then legal frameworks, cultural preservation, the system of the judiciary bodies that we have on the moon, the establishment of a lunar economy, essentially, as well as commercial ventures and the procurement of services, because this type of system I think would be very difficult to maintain without having some type of industry, without having some type of economy that that is supporting it and underpinning it. And so with that, I'll just pop over to the next slide, which is an outlay. This is a bit old now. As you can see, I've kind of added some notes to this slide, but this is an outlay of the Artemis plan for the Artemis missions. And so when we're thinking about long-term habitation on the moon, we need to have a different mindset, because the previous mindset was, we don't have to think about multiple use resources. We can abandon resources. Whereas if we're going there and we're going to stay there, we need to make sure that every single resource we are using is being utilized in its completeness. And we're also more aware now of the Earth space environment than we ever have been before. And that speaks to the increase in space situational awareness, space traffic management that we've seen across the industry. And so the Artemis plan really has been developed by NASA to try and help kind of guide that goal of returning to the moon. But as we all know, there's been several delays across many of the Artemis missions, and they've pushed back those timelines. So examples of this are the recent contracts that were awarded to Collins Aerospace and Axiom Space for the XEMU spacesuits after NASA had massive cost overruns with it. And one of the most crucial delays, which is holding up all of the kind of key Artemis missions, is the Space Launch System rocket, which all three of those main missions hinge on. So you can see on this slide, you've got the CLPS missions, which are delayed to 2022. They're going to be payloads that are delivered commercially, including scientific payloads, robotics, and they've been awarded to a various number of contractors. There's 11 of them, I believe, or 16, sorry, on my slide it says. So though that really shows to me the commercial involvement, not just in some of the other systems that are being built and put in place for launching and getting to the moon, but also for some of the instruments we're going to use while we're there. The Viper rover has been delayed because it requires additional testing. This is going to assess some of the sites where there would be water ice and do an investigation on those. The Capstone satellite, though, is on its way to the moon. It was successfully launched on the 28th of June. And the first parts of the Lunar Gateway have also been delayed back to 2024. But the plan is there, and as with all things in space, obviously we need to adjust according to different conditions that arise. So it's not surprising that the plan has been delayed. But along with that plan, it's not just an engineering concept, right? NASA's given a lot of thought in terms of how we should conduct ourselves when we return to the moon. And that brings me to the Artemis Accords. And so the Artemis Accords, I won't speak too much, but in October 2020, Australia signed the Artemis Accords. And so that's important because not only NASA is planning to go to the moon, but Japan, Russia, China, ESA, South Korea and India, they all have planned lunar missions. And these include orbiters, landers, rovers, sample return missions, crewed exploration, and they're more or less all marked to happen within the next decade. And so this series of Artemis Accords, this agreement, it's built on the 1967 Space Treaty, but it really goes beyond that. And it's about, well, how are we actually going to conduct ourselves? And that includes the involvement of commercial players, of industry, right? So mature agencies are shifting more towards procurement over deployment. Risk is being outsourced to industry, so support services for crewed missions, look at SpaceX, for example, demonstration of technology in automated systems and in situ resource utilization services. And non-space companies are beginning to get the message. They're seeing the opportunity and they're beginning to be engaged as well for expertise in some of these fields as well. So not only does it open opportunities for Australia to be a more active contributor, but it's really a practical set of principles that we will undertake and operate with. And we need to be mindful of this when we're thinking about commercial opportunities. So with that in mind, where does Australia kind of fit into this? Well, to me, I see it as a lunar economy being one which is primarily based off of three main segments. So you're going to have space resource utilization, you're going to have transport, and you're going to have data. And these are the main three to begin with. They're not every kind of industry that lunar economy will include, but most of the elements required for a sustainable lunar habitat will fit into one of these three somewhere along the way. And by 2040, it's estimated this market is going to be to the value of $100 billion. And that only includes activities that have been stated and that we know about. If there's additional missions or other activities we don't know about, it doesn't include those things. And so the first one, transport, is by far the largest segment. And that's because obviously if we're going to set up a presence on the moon, every single component that we listed before has to be transported there, at least initially, including those support services and infrastructure. And the ongoing transport activities will cover things like resupplying crewed mission transfers, as well as the downstream processing of information and plant and equipment. But between now and 2040, it's estimated that 187 tons of transport mass is going to be launched to the moon. And once again, that figure is based on currently known missions. So in terms of what's happening here for Australia, well, there have been several things. There's been the Moon to Mars Supply Chain Capability Improvement Grants, and this is designed to award grants of between $250,000 and $1 million to companies who can increase the capability of Australia to support the Moon to Mars initiative. And now I'm not speaking on behalf of the agency today, but it's worth noting that there are many agency and government initiatives which are directly geared towards getting us back to the moon. We also have other infrastructure developments like SA Space Park. And so this is a $40 million dedicated manufacturing hub. Now, it's not dedicated to manufacturing things for the moon, but if we're going to be manufacturing small satellites, their payloads, rockets, and propulsion systems in a hub like that, then it follows that some of those may find applications on the moon. We also have the National Satellite Manufacturing Hub, which is a $71 million manufacturing hub that's opening international doorways for satellite manufacture with European manufacturers. And this is focused on Earth observation satellites, which are small to medium class satellites up to 500 kilos. But once again, the facility and the infrastructure will be there that we could then use for applications on the moon. There's other applications, I suppose, in terms of transport as well, when we start thinking about human presence, because Sabre Astronautics recently announced that they have a partnership with Axiom Space for a human space flight and commercial research program in which they would be conducting experiments on the ISS. However, that opens a doorway to human spaceflight, as well as the Australian Space Agency investigating the possibility of a framework for human spaceflight as well. So there are plenty of opportunities in transport, even though our own launch capabilities here in Australia are still kind of in their infancy. The next one being space resource utilization. This is really key and probably one of the biggest areas I think everyone can really identify and appreciate the knowledge that we have in terms of mining. But this covers both the scientific and the commercial aspects of resource utilization. And so yes, it's things like establishing mining and manufacturing facilities to extract resources, but it's also transiting those resources, refining them in situ, and then potentially even exporting some of those materials as well. And you could see there's an image of the Trailblazer rover, which is an artist's interpretation. And Kerry spoke to this a little bit before about what that rover's looking to do in terms of it's going to be collecting lunar regolith and then transporting it to another NASA system. And essentially it's looking to extract oxides from the regolith. Now, why is that important? Well, that's important because the lunar regolith is actually about 44% metal oxides on average. So it includes iron, magnesium, titanium, aluminium, silicone, and we can use hydrogen, carbon monoxide, and methane, as well as different electrochemical reduction techniques to extract those oxides. So then we have oxygen, which is part of those support services in terms of habitation, but also one of the ingredients for propellant and rocket fuel. And then we also have materials that can be used for construction. We have metals. So other examples of that space resource utilization would be water ice extraction, right? For the same reason that we can separate the oxygen and the hydrogen, we can actually make rocket fuel from it. And along this supply chain, there's lots of opportunities across all three of these segments that I'm going to speak to you about over exploration, measurement of data in mining, refinement, transportation, storage, and monitoring that we have the opportunity to take advantage of. In terms of what the agency is doing, like I said, I mentioned the Trailblazer program. So did Kerry. That's $50 million towards the development of that lunar rover. There's the Space Resources Environmental Analog Facility, which is part of QUT, and they're going to be building Australia's largest covered outdoor facility for testing equipment, for robotics equipment in lunar environments. And that, similarly, there's the Xteris Lab at the University of Adelaide, which has a regular thermal vacuum chamber, it's called, which is mimicking the conditions on the moon, which allows for advanced testing of robotics hardware. On top of that, UNSW has the Australian Centre for Space Engineering Research, and that has conducted projects including in situ resource utilization, viability studies, and lunar water resource exploration studies. So the last of these three segments is that of data. And when we're thinking about data for the moon, there's a couple of categories we can split that up into. So there's telemetry data. So this is data which is going to be informing us of, for instance, the monitoring of a rover and how that's operating, how that equipment is operating in real time. And then there's also telemetry data which could be used for terrestrial applications back on Earth. So for example, if you're mining on the moon for something and you want to understand the conditions that a drill is operating in, well, that's additional telemetry data that you could then use and apply back to drilling operations on Earth. There's going to be entertainment data. The images that Kerry mentioned before are going to become much more frequent, and we will see these used in things like gaming, VR, and AR, as our entertainment industry seems to just love space right now. And this will be a big part of that data that we're collecting. And then there's also environmental data. And so this is the space resource utilization side of collecting temperature, pressure, radiation, geology, the slope, altitude, and hazards of the surface of the moon, as well as other resources like water, oxides, and regolith. We can look at things like dust content, and Kerry mentioned it does weird things, so we could measure that and understand that a little bit more, as well as the sunlight that certain areas are receiving, and even the gravitational field variation on the moon. So there's a huge, vast array of data which we're going to be collecting. So Curtin University have been doing a little bit of work on one of those areas, which is the lunar gravity model. And that's been identifying different gravity accelerations on the surface of the moon. And this is to avoid gravitation anomalies for landers. It's something that was already applied to Mars missions. On top of this, when we think about data, and Kerry mentioned before about the Deep Space Network, well, we have this huge long history and expertise in deep space communication. So it's very natural, I think, for us to pivot into utilizing that for lunar communications. One of the opportunities there could be in developing something like a lunar communications network that goes beyond, I suppose, that of Gateway, right? So perhaps you could do something that has internet coverage over the surface of the moon, or something similar. An area which is going to be of increasing priority, not just on the moon, but also on Earth, is cybersecurity, or it already is. There's going to be increased data flows around the world, as well as those data streams coming from the moon and the lunar economy. And Australia has been investing in this area to the value of about $1.7 billion. And so cybersecurity is another key area of opportunity for us. And the last thing I'll mention on this is an idea which is the Lunar Water Index. And this is a plan that NASA's put together in terms of predictive modeling using orbital measurements and lander measurements to study and identify in more detail the water resources that are available on the moon. And I actually came across this idea a while ago now as part of some work that I do with UNICEF Global. They run a mission idea contest, and one of the submissions for that was a constellation of satellites, which is essentially establishing a comprehensive lunar water index of the whole surface of the moon. So some really interesting applications, I suppose, and opportunities there for data. And in terms of how we seize them, well, this image here, I thought I'd share with you because it was generated by the Space Industry Association of Australia. It details the organisations that make up its member base. So this isn't by any means a comprehensive list of organisations. There's many more than this, but it just highlights the diversity that already exists within the space industry in Australia. And, you know, we could extend this list, I suppose, as more companies in mining, medicine, defence and agriculture come on board as well when they start seeing these opportunities for them to contribute to lunar missions. But the space industry in Australia in a few years ago was valued at about $5 billion. And there are only about 10,000 people working in the industry, but the plans for that are far more than I suppose what we could imagine, with tripling the size of the GDP and increasing the amount of jobs to 30,000 by 2030. So it's a really ambitious plan, I think, which is space related directly, not necessarily the moon, but I could imagine that many of those jobs are going to be angled towards lunar efforts. So in terms of Australian industry, though, I thought I'd share this with you because I found it interesting. And this is in 1990 what the four kind of biggest markets in Australia in terms of GVA looked like, and their share, I suppose. So you can see that for the last kind of 30 years, actually, these markets have been influential. But these four industries all have significance for lunar habitation and establishment of a lunar economy. And if we skip ahead to 2021, you can see that the overall gross value output of these markets has changed a little bit. Each one of them is still, quite strong. They're our largest markets in the country. And the other thing to consider here is that by 2023, the International Monetary Fund actually predicts Australia is going to have the 12th largest economy in the world. So we have a population which represents 0.3% of the world's population and 1.7% of its economy. We are punching well above our weight in terms of many outputs. So manufacturing is one area which has slipped, I suppose, but this is also an area which is being revitalized. And this is across areas such as resources and medicine, energy and space, actually, as being identified as those key areas for the government. And there are manufacturing initiatives in the billions of dollars which have been established to support this. And many of these will include technologies which are transferable to lunar habitation, as well as that focus on cybersecurity and agricultural tech that I mentioned before. And there is also, too, I forgot to mention, the agriculture dot point here. I've listed that while it's not one of our largest markets. There's some really interesting work being done at the Waite Research Institute on optimizing plants for nutrition, for food, as well as for pharmaceutical. Yeah, I didn't put defense, Adi. I'm talking about civil things, and I suppose I'm not looking at defense strategies on this, but the way that we can apply our agricultural knowledge is numerous. The use of robotics and automation, but also that kind of plant science and understanding how we can produce better medicines in space as well is all going to be critical and areas that we can also exploit. So I think that's pretty much what I wanted to cover and where I wanted to end it. I just will leave you with a final thought, which is that although our space industry is still maturing, there's many opportunities that exist for us in terms of lunar applications. And there was a report released by the CSIRO in November last year that shows that for every dollar you invest into research and development, it returns about $3.5 worth of economic benefit. And so Australia's tech sector is worth about $160 odd billion. It's ranked in the top 1% of the world's scientific institutions. And we excel in things like space science, physics, computer science, and medicine, right? They're among our greatest academic outputs. So I think it really does highlight that not only we're ready to leave the cradle of the earth, but this time we actually have the industry and the expertise to back us in becoming lunar. Thank you very much for your kind attention. I appreciate it.
Thank you, Nate. There's definitely a flavour of Back to the Future there, so that's exciting times ahead. Unfortunately, James Brown from the Space Industry Association couldn't make it tonight. Instead, Dr. Tim Parsons has decided to jump in all the way from Japan. So he's definitely a veteran of startup innovation within the space sector, leading the New Space Network, Delta V. He's also a key member of the SmartSat CRC and has a PhD in rarefied hypersonic flow simulation from the Imperial College of London. I'll hand it over to you, Tim, and thank you again for making your time tonight.
Thank you. You're so welcome. So I'll just add, I'm standing in for James. I'm the chair of the Space Industry Association Australia, which means I get to work with many of the folks on this call every day or regularly. And I'm currently up in Tokyo at a conference called Space Tide Japan, which is claimed to be the largest space conference of its type in Asia Pac. And so I've got a very interesting kind of perspective. It's day one today, so end of day one, I've just finished. And then tomorrow I'm going to be on a panel alongside one of the senior members of the Satellite Industry Association of India, which is sort of our equivalent body in India. So it's fascinating kind of to compare and look back at Australia from Japan, where I am right now. And I think, so, I've got some reflections. And by the way, I don't have any slides. I've had about 30 minutes notice to jump into this. So I'm going to give some thoughts. These are my personal impressions. And I'm going to steal shamelessly from Nate and probably a little bit from Kerry, who I really learned a lot in a couple of your slides there, Kerry. Thank you so much. I hadn't ever seen that picture of the astronauts and all the frequencies that they were using. That was super geeked me out. So I think one of the things that probably the first big idea I want to give everybody is that Australia has a thing called last mover advantage. And it's not a joke, because you may know a search engine that's quite popular. It's called Google. Now, if you're old enough to remember the period during a dot-com period around 1996 to 2004, like I was, you'll realize that Google was the last big search engine that got released, and it just happened to be one of the best. So all those things that Nate just rattled off, top 1% of universities in the world, really, 12th largest economy, incredibly sophisticated workforce, and an ability to drag people from overseas. And kind of when they move to Australia, they're kind of screwed. They have to stay, right? Our kind of, these are sort of unfair advantages we have in Australia. The other aspect of this last mover advantage is that we've chosen a moment as a nation, I would say kind of unconsciously in a way. A lot of us spent many years advocating for this moment that we're in now, but certainly we've chosen a moment where the cost of going to space, the cost of space systems has dropped dramatically. And by dramatically, I mean about 100x from a system level. And certainly McKinsey just released a report recently where they made an estimate of the cost differential from previous, for example, satellite systems from, say, 15, 20 years ago to the equivalent performance satellite systems for today. And they came up with a number for that. And then they compared that with the change in back in the 80s from the mainframe computers to the PC. So they estimated that the change from mainframe computers to the PC was about a 2000x performance gain for a given dollar, right? You put $1 into a mainframe computer, you put $1 into a PC, actually you get 2,000 times more performance from the PC. So McKinsey estimated that today's satellites are 3,500 times better performing than satellites from 15 to 20 years ago. How does that come about? Well, it's come about because of a whole stack of factors that work to our favor in Australia. One of them is miniaturization. I'm sure many of you are sitting within arm's reach of a phone, right? Which is, by the way, a satellite, just happens to have a nice touch screen and stereo speakers, but it has a battery, a camera, an antenna, positioning system, etc. So anyway, so the microelectronics revolution that drove the PC and the phone has enabled a whole new generation of entrepreneurs and engineers to say, hey, why don't we fly phone technology into space? Why don't we take PC technology and put that into space? What could possibly go wrong? And in fact, they have learned that in many cases, the technologies are as good as, if not sometimes more superior than the exquisite material, exquisite kinds of subsystems that people were building in the space sector before. That's not always true in all cases. There are certain things like a star tracker, which you don't really need on a phone. But it was certainly true for an enormous amount of things like CPUs, processors, memory. And in fact, because of the scale, we've had billions of these phones made, things like memory has become so cheap that many spacecraft just say, look, if we just run error detection over our memory, if cosmic ray particles knock out certain memory banks, we just turn them off. We've got plenty to spare. So, quite a few spacecraft now just run with little SD cards, literally, to store information in them, kind of off the shelf. So off the shelf, microelectronics has allowed us to create space systems that are much, much cheaper, and it allows us to iterate much more quickly, both on the ground and in space. So that's one factor. Another big factor is in Australia, especially over the last 4 years, we've really had a lesson in disasters. We had these massive bushfires, followed by a whole series of La Nina events, massive floods. We had this huge global pandemic. Suddenly all our supply chains got under stress. We've learned facts like a major modern city has about 24 to 36 hours of supplies of food. Our just-in-time supply chains are so optimized that actually if you cut off a city from its surrounding supply chains or from the global supply chain, literally you only have like 36 to 48 hours of food in a city. So in other words, a whole lot of things made us feel less comfortable about our infrastructure. And suddenly we realized, gosh, in those big bushfires, we were completely dependent on a Japanese satellite, Himawari 2. We were completely dependent on overseas-based GPS positioning satellites. We were completely dependent on a whole lot of services and systems that we don't own, we don't operate as a country. So this factor of choosing the moment where the cost of building sovereign capability, sovereign systems has dropped so dramatically, and then suddenly we've realized, hey, a modern society, these phones, these computers, these communication networks will not work without space connectivity, space-based positioning and timing, navigation, and of course communications. So this is kind of our modern society. So those are kind of two of the factors to add to the wonderful set of things that Nate added. And then I think really, really importantly, one of the points that was made up here in Japan is where our generation is much, much more dependent, as an advanced society on space than our parents were day to day. And our kids are going to be even more dependent on space services and systems for life here on Earth. Now, okay, one of the kind of themes of the talk that I was asked to talk today, and I'll only speak for another 5 or so minutes, is, emerging. I've got the Earth here, emerging from the sun, from the moon. There it is. The emerging space sector. So in Australia, what a lot of our tech entrepreneurs, as well as experienced business people, have realized, okay, actually, space industry is suddenly going through a growth spurt. It's actually growing faster than Melbourne real estate. It's had a compound annual growth rate of over 10 to 12% over the last decade, and where predictions are that it's going to, even with the recessions that everyone's talking about, it's going to reach over $1 trillion early in the 2030s. And a lot of the areas where huge value is going to be created are in downstream services, like using Earth observation, positioning, imagery to do much better optimization, to drive power systems, water systems, transport networks, resilient supply chains towards more sustainable outcomes, right? Using less energy, less food waste, and also delivering on a whole host of sustainable development goals, both in first world countries like Australia and lower income countries around the world where there are challenges. So we're also seeing, we're talking about the moon. We're also seeing this, as Nate and other speakers I'm sure have talked about, that, you know, when you go to the moon, you are actually taking the Earth with you. And you have to take a facsimile of that Earth and figure out how it works. You have to figure out, how does our endocrine system work? How do we take billions and billions of bacteria that live in our gut that we absolutely depend on for a whole host of hormones that our brain depends on? How do we take that to the moon? We've all been through lockdowns. I'm sure many of you have found that for the first time, like I have. Wow, I have mental limits. You know, I have areas where I just get brain fog if I spend too much time sort of trapped in front of the computer. I don't have brain fog right now, of course, because I'm speaking to you. But so how do we take people up to a place like the moon or even Mars and have them there for an extended period and not have them kind of brown out? How do we deal with health emergencies? How do we deal with actually in situ resource utilization? And what can we learn, as we've said, that will then help us drive incredible value on the Earth? So one of the things that, you know, many of the astronauts I've met one or two Apollo astronauts who've walked on the moon, like Charlie Duke. I've met people like Pamela Melroy, who've been up in the space station, commanded the space shuttle. To a person, I think I'm up to about 8 astronauts. Every single one of them talks about the first thing they did was look back at the Earth. They looked back at the Earth and they saw that there were no borders. They saw that it was an incredibly beautiful jewel. So I think one of the really big themes that we also have in Australia is that we now have this sense of, okay, all of those industry sectors we're talking about, we need to turn them into sustainable industry sectors. We are a country that has incredible leadership globally, and space is one of those things which allows us to have an incredible perspective on our planet. So industry is now kind of leaning in, and the emerging industry is in the form of startup companies. It's in the form of SMEs. And those companies exist because they are managing to deliver space services and systems at a massively reduced cost. And increasingly, governments around the world are saying, you know what, we should stop doing this ourselves. We should start to buy this from industry because it's going to be so much cheaper. So now there's a big word that's coming up around the world in space, in big space agencies like NASA, like ESA, like JAXA, even like ISRO in India, and many others, which is unbundling. Many of the cases, they're deciding that their core mission, which is often about research or about humanity's place in the universe, their core mission does not mean that they have to run huge infrastructural systems. Actually, they're deciding that they would save a lot more money and deliver a lot more outcome if they bought those systems from industry. And so that's the big thing that's playing out. Going back to my opening theme, last mover advantage. The Australian space sector and the Australian space industry are very unique. The Australian Space Agency is not a research organisation. It is not an organisation like NASA. NASA is a research organisation that just happens to do a whole lot of things, including human spaceflight. But they are actually saying to us, you know what, you shouldn't be like us. We are a research organisation that is going to unbundle, and we're going to start to try to build and drive industry growth. You guys in Australia, you have started at the right point. We have 2 KPIs, 20,000 new high-tech jobs in the space industry, grow the industry to $12 billion a year. Hang on those 2 KPIs because they're unique in the world. If there was third KPI that Australian Space Agency and many of us talk about, this is a final strength of Australia, and I'll finish. It's how can we be leaders in making space sustainable? How can we make sure that when we launch things into space, we bring them back or we destroy them and make them disappear? How can we respect the lunar environment? How can we learn from our First Nations elders who teach us about country? What does the word country mean in the context of the moon and Mars? How do we go to these places and do it in a way which is commercially, economically viable, smart, a backup plan for humanity, and yet also respectful of those places? And how do we then learn how to sustain life on Earth and not keep pushing up against these planetary boundaries? And I think those are things that startup companies in Australia are really interested and engaged in, at the same time that they're building rockets, launch bases, satellites, quantum computing, timing devices, spacesuits, VR simulation, flat sats, and everything in between. And they're starting to get engaged in global supply chains all over the world to build that, $20,000 plus jobs, $12 billion a year industry. And they need you. They need lawyers, project managers. They need tradies, electrical engineers, people who know how to teach, people who know how to communicate, people who are passionate and can do accounting. They need all of those skills in the space industry. So we need you, and I encourage you to lean in, and that's I'll finish on that.
Thanks, Tim. I think it's safe to say you don't need slides when you've got that level of enthusiasm. So thank you for that. So for the last session for tonight is our keynote speaker, Michelle Hanlon, which is dialing in from the US. She'll give us an insight into what it means to protect historic achievements as a foundation for lunar governance. A space lawyer, Michelle is co-director of the University of Mississippi's Air and Space Law program and editor-in-chief of the Journal of Space Law, one of the oldest journals to date. She's also co-founder and president of For All Moonkind, a nonprofit organization that is focused on protecting human cultural heritage in outer space. Over to you, Michelle.
Thank you. Thank you so much. Hi, everybody. Good morning, good evening, good afternoon. It's so great to be here. I'm so delighted to have been invited, and I really thank you for the opportunity to chat. I'm so inspired by everything that's been said this morning or this evening by all you all. Tim, especially, you mentioned lawyers, and most people think, oh my God, we don't want lawyers in space, but we do need them. And Alice, of course, is one of our founding advisory council members and has been guiding For All Moonkind for several years. And so I'm going to share my screen and just talk a little bit about what sort of really building on what Tim talked about and doing space and exploring space responsibly. And really it's music to my ears to think about, sustainability and going here. We're on this cusp, we're on this threshold of so many fabulous things. And it's a great day today, International Moon Day. And congratulations to the Moon Village Association for getting the United Nations to recognize International Moon Day, and also congratulations to AAA for the new chapter. But really reflecting on what we've done and how we can move forward from it, again, responsibly and sustainably. So just to start, my name is Michelle Hanlon. I'm the co-founder of For All Moonkind. We're an entirely volunteer organization that is focused solely on protecting human heritage in outer space. And so we've been in existence for 5 years. Alice Gorman was instrumental in the formation of our ideal. And in our very short life, we have been able to do a lot. We've gone from sort of we need to protect space to getting national legislation in the United States, the One Small Step Act, which recognizes that we have heritage in outer space. And of course, Section 9 of the Artemis Accords, which has come up a couple times this evening, which has an entire section devoted to protecting human heritage in outer space. And so we're sort of still bringing the international community into this concept that we have heritage in outer space and that we need to protect it. And we're really calling upon now, and again, this is something that Tim pointed out just now, we're really looking at commercial space, and we're really calling on commercial space and new space and legacy space to pick up this ball and run with it and recognize that to be responsible, to be sustainable, we need to start by protecting our heritage. I'm also the co-director of the Center for Air and Space Law here at the University of Mississippi. I run an amazing course in the fall called Astropolitica. So if you have any interest in continuing the conversation about exploring space law after this, then I will share my slides with you. But this is the QR code. Check it out. It's an awesome course. So you can also earn your LLM and a graduate certificate in space law. So, what are we here today for? 53 years ago, 650 million people were glued to their television sets, right? 650 million people. That was more than that's a universal event if there ever was one. These are pictures from Australia. I'm sure you guys recognize them. This is the David Jones department store, and this is Sydney Airport. And so people stopped in their tracks because 53 years ago today, a human being, one of our own, took a step on another celestial body. What a moment. I mean, what a time for humanity to come together and celebrate an incredible achievement. Of course, not everybody was really happy, right? There are a lot of issues going on Earth in 1969, just like there are today. And so even as the Apollo 11 launched, there were protests at Canaveral. This is Ralph Abernathy said, you know, why are we spending so much money exploring space? And this is also a question we get all the time today, right? Why are we spending so much money now? It is a lot easier.
Hey, Michelle,
to answer.
just to jump in, your presentation showing the speakers view as opposed to the full slide at the moment.
Sorry. Let's see. I was on such a roll. Let's see. So this one. Better?
Yep, that's perfect.
Okay. Anyway, sorry about that. So never mind that interruption. So, you know, we have a lot more ammunition now, right? We can say, well, of course, we know all of the benefits of space we've already gotten, the least of which is you know, the remote sensing capabilities, being able to observe our Earth and understand climate change. But what's really important about this picture and why I put it in is, yes, Ralph Abernathy organized a protest, and he actually asked to speak to the NASA administrator, and Thomas Paine came out and talked to the protesters, and they got together, and Thomas Paine said, you know what, if I could give you, if I knew all this money that we spend on space exploration would actually solve these problems, then I would give it to you in a heartbeat. But we know it's not going to. And we know that we need to keep exploring. And at the end of the conversation, they all held hands, the protester and the NASA administrator, and they prayed for the astronauts. And so, you know, I don't today we don't pray, whatever, but the point is, division is part of humanity, and understanding other people's issues, other people's problems, other people's concerns is part of what makes us tick. And it's part of what we bring with us into space. And so when we celebrate this day, when we celebrate our technological achievements, we have to remember that there are people that aren't necessarily understanding the benefits they're receiving. And I think so far, and I again really love, Tim, your presentation off the cuff with 30-minute warning, but just talking so deeply about, you know, this is what we're doing is for all of humanity, and we just have to recognize that and keep that in the conversation and continue to share that with everybody. So, sorry, now I'm on different screens. Okay, so also what we sent to the moon were messages of peace. Just before about a week before we knew that Apollo 11 was going to go to the moon, a NASA flunky wrote to every single embassy and said, hey, we're going to go to the moon. We're creating this special disc. This is a disc the size of a US $50, and we want to put messages of peace on it from every nation in the world. 73 nations responded. Well, more responded. 73 nations made it in time. A lot of nations thought, oh, well, you know, they were a little bit confused what was going on, but Australia made it. And so we have this message from Australia on the moon as part of this disc on the site of the Apollo 11 lunar landing in Tranquility Base. And I love this thought that this achievement possible to be so used in the future that humankind will live in a universe in which peace, self-expression, and the chance of dangerous adventure are available to all. So yes, we are risk takers as a humanity. Some of us don't want to go to space. Some of us do. The fact of the matter is we need both types in order to be sustainable, both on Earth and in space. So it's without question, as we think about moving forward, that the decisions we make today with respect to the potential legal model for activities in space, and this is what we're talking about being responsible in space, is going to have far-reaching implications for humanity, for future generations, for our entire future. So the decisions we make today with respect to how we go to the moon and how we use those space resources and how we relate to each other in space are going to be the foundation for the future of humanity. And so I tell my students, I teach space law here at the University of Mississippi. I tell my students all the time, this is so much more important than you can, like you roll out of bed and you come to my class, but you really have to realize that you are going to be making the decisions. This next generation is making decisions that are going to have implications for centuries to come. Think about the Constitution, think about the Magna Carta. This is where we are with space law. What we do today, the little tiny decisions we make are going to have far-reaching implications into space law. And so, I believe that we're moving away from this sovereign paradigm. I believe that the sovereign states have a really deep obligation and responsibility to help us herald in this new era of humanity, in which more of the private individual, more of the commercial entities are going to take that responsibility. And so one of the first things that we have to think about, and one of the first things that I always talk about, and one of the first things that that commercial entities repeat back to me or mirror, is that we have to protect our cultural heritage in space. There's not one person, not one company, not one country has ever said out loud, oh, we don't need to protect the Tranquility Base. We don't need to protect that boot print. Who cares? No, we need to protect the first footstep, humanity's first footstep. We need to protect the Lunar 2 site, whatever may exist of it, the first human-made object to impact the moon. And why is that? Because these are the baseline. These are what makes us a community. And we want to go into space as a human community and not as separate individuals and separate nations. And so For All Mankind is spending the next sort of 5 years of existence talking about the need to have heritage protection zones, safety protection zones. It's something, again, that Carrie, I think, brought up. There's this plume effect. We know that there are these very difficult environments that we have to deal with on the moon and on Mars. And so we need to have protection zones to protect operational, commercial, and also to protect heritage. And so when we think about how we're going to explore space responsibly, the first thing we have to do is think about protecting ourselves. And the first thing is to protect our heritage. So, of course, this is not a new idea. We do it down here all the time. This is back in 1813. We recognize that when there is a human achievement, it belongs to humankind at large. That's why we all protect and are in awe of the pyramids, the Great Wall of China, Stonehenge. And so we did it in 1969. Excuse me. It's morning here, and I still have my pre-coffee frog in the throat. So apologies for that. So back in the 1960s, Egypt decided that it needed to modernize and develop. And so what did they want to do? They needed to harness the power of the Nile River. They wanted to put a dam up, and putting up that dam was going to flood the Nubia Valley. The Nubia Valley, which is considered one of the cradles of humanity, right? Of our civilization. And so Egypt went to the international community and said, hey, we really want to do this, but we know these artificial pressure. What did the international community do? We didn't say, no, you can't do it, Egypt. You cannot develop. You have to protect. You have to save these things. And they didn't say, oh, who cares? Just let them be flooded. They said, okay, let's help you. Let's come together. And the international community came together and raised $80 million in the 1960s and created the technology, engineered it so that they could remove these temples piece by piece out of the Nubia Valley onto dry land so that the Nile could be harnessed, so that Egypt could develop and modernize. The international community came together in this spirit of kinship and this common responsibility to protect that heritage and help development. And that's exactly what we need to think about with respect to the moon. So out of space, what came out of the Nubia campaign was the World Heritage Convention. And so we know every nation on earth has ratified the World Heritage Convention, and that recognizes the universality of human accomplishment. But the problem with the World Heritage Convention is that in order to apply it, you as a nation have to say, oh, this is something in my territory that we think ought to be considered human heritage. So please, UNESCO, United Nations, international community, recognize it within their territory. So I know a lot of you are not familiar with space law. I'm going to talk about it now briefly, but Article 2 of the Outer Space Treaty makes it very clear that a sovereign cannot claim territory in space. And so the United States cannot go to the UN and say, hey, we would like Tranquility Base to be a UNESCO World Heritage Site. China cannot go to the UN and say, we would like Chang'e Fort to be considered, where it landed, to be considered a World Heritage Site, because that would be claiming territory. That would be saying that's within our territory and this should be considered. And we've actually, For All Mankind has actually approached the UNESCO to say, hey, let's look at this World Heritage Convention and see if we can expand its borders. And UNESCO said, that's a really good idea, but the problem is we have so many issues here on Earth with conflicting borders, we don't even want to think about space now. So we need to think outside the box and think about something completely different when we think about space. So what do we know? We know that nations of the world have proved unanimous support for the protection of human heritage with the World Heritage Convention. We know that there is no heritage more universal than the lunar landing sites on the moon. We saw that. I started this presentation with pictures from Sydney Airport and the David Jones department store. 650 million people watched that landing. Each of these accomplishments, every single accomplishment on the moon, is a result of milestones in human evolution. You know, we don't get to the moon without our entire human history. And so these are uniquely universal events of human history of which we can all recognize and take a part of. So there's nothing more global and more universal. There's no heritage more universal than our heritage in space. But like I said, space law has gaps. So I said, mind the gap and the inconsistencies in space law. And so we're going to do, I know we're really short on time, so I'm going to sort of give you like space law in 2 minutes. But the first thing that you want to remember when we talk about space law is the space law treaties were negotiated in the 1960s and early 70s, a long time ago. Okay. And the main idea behind the space treaties was to keep the peace in space. And I want you to remember, I put this picture up because our worldview in the 1960s, our universe view, is very different from what it is today, right? We didn't really understand space. We had this concept of the universe being infinite, but we were really sort of, thinking about our solar system. Now, this is what we see space as now, right? I mean, this is what an incredible week it's been to see these visions, these beautiful pictures of what space is. And so the very first sentence of the Outer Space Treaty talks about space being the province of all humankind. And I just want everybody to take a minute and reflect on that. This is the province of all humankind. Okay, so on the one hand, yes, that is really glorious. But on the other hand, is there ever a more hubristic statement to be made? How does this belong to humankind? This is so much more than humankind, right? So I want you, when we talk about space law, put that into this context. We were thinking space, like, okay, there's these planets, we need to think about them, but space is beyond our comprehension. I mean, to think that we can put laws in space is just remarkable. So what can we do? We're not trying to regulate space. We need to prepare guardrails around human activities in space. We can't say space is the province of all humankind, but we can say space is an area that's really special. And we need to look at the law, and we need to remember that law is about human relationships. It's not about regulating this or regulating that. It's about human relationships. And in that, it's about human relationships with each other and with the space around us. So, okay, space will be the province of all humankind, but let's go back to that Outer Space Treaty. 1960s, we thought we owned the universe. We were really concerned about keeping the peace in space, and the Outer Space Treaty has done a really good job of that so far, but there are a lot of gaps. But fundamentally, the Outer Space Treaty says it's the province of all humankind. We will have free access to all areas of celestial bodies. Anybody can do anything they want in space, anywhere. Okay, that is what the Outer Space Treaty says. Nothing. There are very, very few limits on what humans can do in space. The limits are encapsulated in Articles 2 through 4. Article 2, which I already alluded to, says a sovereign cannot claim territory in space. You can't go up into the moon and plant your flag and say this belongs to us. But we did see, and again alluded to earlier this morning, we can use the resources we extract from space. That's a whole nother lecture. Article 3 says international law applies in space. So humans, when you go to space, it's the province of all humankind. You have freedom of access and exploration, but international law applies to include, we hope, international human rights, which include, and this is one of the inconsistencies, Article 17, the right to own property in space. Okay, so already we're sort of like, wait, what? And then, of course, Article 4 is the fundamental, the reason that the Outer Space Treaty is successful and exists: no nuclear weapons or weapons of mass destruction anywhere in space. Unfortunately, it doesn't say all of space shall be used for peaceful purposes. It says the moon and other celestial bodies for peaceful purposes only. So again, just to show you, we have this Magna Carta of space that's looking at human activities in space. Really, it was designed to look at sovereign activities in space. And it said, sovereigns, you can do anything you want, and your nationals can do anything they want, except that you can't appropriate. International law applies, and we're going to really try and keep it peaceful. The only other thing that restricts our activities in space is Article 9, which talks about due regard. All states parties shall conduct their activities with due regard to the corresponding interests of other states. And if you think that you're going to do something that would potentially cause harmful interference, then you should have a consultation. So no, we couldn't even back in the 60s agree that we wouldn't harmfully interfere with each other. We said, if there's going to be harmful interference, then we'll have a consultation. Again, the Artemis Accords do take that one more step and try to prevent harmful interference. But I really want to focus on this due regard, because this concept of due regard is the only thing that restricts behavior in space. And what does due regard mean? And it doesn't mean anything. In civil society, it means we're going to be considerate of each other. In law, it means it's a balancing test. There's an ICJ decision, which is a bunch of legal gobbledygook about we're balancing this interest against that interest, and then look at this, and then what activities was hindered. And that's not a way. First of all, that's not a way to provide investors with the certainty they need to invest in space exploration. And it's certainly not a way to protect our heritage in space. Few would argue that the sites where humans first set foot on another celestial body should be recognized and protected any less than any site here on Earth. So as we consider sort of models for legal activities in exploration and exploitation and utilization of space, we urge delegates, we urge the international community to reach an agreement on what due regard means. And, we talk, For All Mankind is a permanent observer to the COPWIS, so we talk to delegates, but we also are reaching out to the new space community and the legacy space community, to commercial entities. What does due regard mean? We have to agree on what due regard means in order to explore space, explore the moon sustainably. And while it may be argued that, we have a lot of time to think about it, right? There's a long time before we're actually mining on the moon. The fact is that anything we do on the moon is going to have an impact on our history on the moon, on our artifacts, on those lunar landing sites, whether Luna, Chang'e, or Apollo, or Surveyor, or Ranger. immediately, because of the plume effect. Anytime we have activity on the moon, it's going to create that plume effect. Phil Metzger here at the University of Central Florida has shown that if we were actually to land some of the rocket bodies that we're thinking of landing on the moon, that plume effect, that regolith, will impact lunar orbit and impact gateway. So we're looking immediately, what is the most vulnerable thing that we have on the moon? What is the most important resource we have on the moon right now? What do we really have to worry about right now? It's our cultural heritage on the moon, those lunar artifacts and those lunar landing sites. So we already have this concept of safety zones, and they can, we have them in the Artemis Accords, we have them in the Space Resources Working building blocks. Russian law has them in there. We have the concept of safety zones in NASA with the NASA guidelines, which are voluntary guidelines. There is a lot of discussion of safety zones. It is time to implement some sort of concept of safety zones before we go to the moon. Let's understand how we are going to protect not just our operational, but our history on the moon, because that is what's going to build our communities on the moon. How do we do that? We need to get expert. We need to have the international community come together and get expert testimony from geologists and engineers and scientists to understand the plume effect. What we don't want is, we don't want somebody to say, okay, I've just landed this on the moon. It's the first clock ever on the moon. And so we need to have a safety zone around it that's 10 kilometers. And all of a sudden we've restricted 10 kilometers of the moon. That's untenable. But we need to agree. We need to agree what kind of risk we're willing to take with respect to each operation, with respect to each piece of cultural heritage. We need to understand what that risk entails. And people like Alice Gorman can tell us that. How far should we be before we can get to the Apollo Tranquility Base? How close can we get? And with technology, we don't have to send people in and scuff it up right away, right? We can wait, we can seal places off until we have the technology to go and protect things and preserve them correctly. So from Luna 2 to Luna 9 to Apollo 11 to Chang'e and everything in between, our history in space, these are our greatest technological achievements, and they deserve special recognition. And when we think about safety zones, if we start with the concept of temporary heritage protection zones as part of a first step, so we don't go and we say, okay, we don't go through Artemis and say, all right, we are putting up this mine, we are sending this robot for a return mission to bring back regoliths to Australia. And so we need a 2-kilometer safety zone. No, we start with temporary heritage zones, and we take this concept of safety zone and we take it from a keep out, this is mine, keep away, to an idea of conservation and inclusion, right? We all recognize that this is a site that is important to all humanity. And so as humanity, we are going to take this and set it aside. And then we have changed the concept of safety zones on its head and taken it from this concept of exclusion to one of inclusion. And so we really believe at For All Mankind that we need to take that and do that. That's the only way, first of all, that we'll reach agreement on heritage zones, because like I said, nobody's ever said, no, we shouldn't protect the Luna 2 site or the Apollo 11 site. The question is always the how. And so if we can memorialize in writing our agreement that we have history, go one step beyond the Artemis Accords saying, okay, there's history in there, but talk about how we're going to protect it. That will be the first agreement we have with respect to the concept of safety zones and something we can work from. So this is our generation's Nubia moment, except there's no price tag attached. It's not going to cost us $80 million to say there's a safety zone, a protective zone around these heritage sites. It's just a responsibility. It's picking up the mantle, shouldering that responsibility, and understanding our intergenerational equity and the need to protect our future and protect our community. And so I challenge all of us on this call to really think about how we want our spacefaring future to look, because inevitably, and we know that we are intertwined, even if you have no interest in going to space, our lives here on Earth are intertwined inextricably with now and forever on. And we are going to be a spacefaring species. And so recognizing heritage outside of the norm of sovereign territory will provide a matchless gift, the chance to recognize incredible technological achievements, not as national triumphs, but as human triumphs. And we can take that step now to assure a common responsibility towards the past so that we can move forward into space, onto the moon and beyond in the spirit of kinship. So thank you very much. I know I did it quickly because I know the most fun part of these panels are discussions, and I know we're running out of time, but I really, really appreciate the opportunity to be able to share my ideas with you. Thank you.
Thank you, Michelle. So that now concludes the, I guess, the speakers component of this afternoon. So firstly, I'd like to say thank you to everyone that's made their time to, one, be here as an attendee, as a speaker as well, but everyone on the webinar itself as well. I think one of the important things coming off the back of today is, whilst today's the first official commemoration of International Moon Day, it's been something that has been occurring since 1969. But most importantly, what we do today may not impact us directly, but will impact our children, our children's children. And so it becomes more and more important to really piece all these pieces together and make sure what we do going forward is sustainable. And hopefully one day there'll be an International Mars Day commemorating something similar. So now I'll pass across to Summer that will talk us through the process for the networking component of this afternoon or this evening.
Thank you so much, Dash. So yeah, we'll now head into the networking session. We're going to jump onto a new Zoom link, that way everybody has the same rights and everybody can jump on, show their face and ask questions if they wish. So I've posted that Zoom link in the chat again just then, if everybody wants to copy that before they jump off this session. I know we're running a little bit behind schedule, so we'll run the networking starting now when everyone logs off for about 30 minutes. We'll start with Q&A. There's been a couple of questions asked, and anyone that has questions can feel free to just raise their hand in the networking session as well and ask. And then we'll open it up for some further discussion. There have been some awesome points mentioned in the chat throughout the webinar, so I look forward to hearing more about it. And hopefully I'll see a bunch of you over in that other Zoom link. Thanks, guys.
Well done. Fantastic. Well done, everybody. Thank you so much. It was wonderful.
That was great, everybody. Thank you so much. I'll see you
Good
in
job, guys. I'm
in
going to
the
jump over to
networking
the
room.
other link so that someone's in there.
See you.
I'm afraid I'm going to have
You did.
to love yous and leave yous. I'm just really failing. So I hope you have a good networking session.
Thank you very much, Kerry.
Yep. I'll see you later. Thank you. Thanks for inviting me. That was great.
Okay, I'm going to go to the Zoom room too, to the networks too.
See ya.